Hey everyone, welcome to this explainer specially designed for you, the sixth semester industrial engineering students at Universitas Islam Bandung. Today we're tackling one of the absolute biggest hurdles in product design. I'm talking about how we take those vague, messy, sometimes confusing consumer needs and translate them into concrete, actionable design goals. Because as engineers, well, you can't just build a product based on a hunch, right? You need a solid system. So let's dive right in and explore a proven methodology that literally bridges the gap between what users say they want and what we actually need to engineer. Here's a quick roadmap of what we're going to cover today. We'll start with the elderly smartwatch problem, look at the clarifying objectives theory, learn how to separate objectives from means, build an objective tree, and then wrap things up with a conclusion. All right, let's jump straight into section 1, the elderly smartwatch problem. Let's start by looking at our focus case study. So, currently, the smartwatch market is absolutely booming, but it has a massive blind spot when it comes to elderly users. These devices are overwhelmingly designed for young people, or fitness enthusiasts, and when those exact same designs are marketed to the elderly, they often fail completely. Why? Because they totally ignore the specific ergonomic limitations and the really urgent emergency needs of older adults. Just notice how current device problems directly cause severe negative outcomes. We're talking about screens that are just way too small and lack contrast. That's a massive issue for users with presbyopia. They literally just can't read the text. Then there's the emergency SOS feature. On a lot of devices, calling for help means you have to navigate through these complex little submenus. In a panic or after a fall, that is completely useless. It requires a one-touch action. Add to that a short battery life of maybe just 1 or 2 days, which leads to dead devices because an elderly user might simply forget to charge it every single day. And finally, notifications and alarms are often way too soft, meaning a user with even mild age-related hearing loss won't even notice them. These aren't just minor inconveniences, guys. For an elderly user relying on health monitoring, these are severe, potentially life-threatening usability flaws. That brings us right to section 2, clarifying objectives theory. So how do we actually fix this? Well, we move to our core engineering challenge. We have to transform those abstract consumer complaints into structured design objectives. And to do that, we turn to the clarifying objectives methodology established by Nigel Cross back in 2008. See, consumers rarely speak in engineering terms. They speak in frustrations. They say things like, "It's too hard to use," or "I just want it to be safer." As an industrial engineer, you cannot simply take those vague, abstract, or implied desires at face value. You've got to use a structured method to translate them into clear, measurable design objectives. Because if you skip this step, you risk making fatal design assumptions or creating products with conflicting features that ultimately just fail the end user. The ultimate tool for this translation process is the objective tree, or as we call it, pohon tujuan. Think of this as the master blueprint of your product's purpose. It's basically a hierarchical diagram. It starts with your highest level goals at the very top, the broad reasons the product even exists, and then branches downwards, visually connecting those broad goals to highly specific, actionable, and measurable engineering criteria at the bottom. Okay, let's really break down the mechanics of this process. According to Nigel Cross's 2008 framework, clarifying objectives requires 4 meticulous steps to ensure we capture exactly what the product must do, rather than what we just assume it should do. Step 1 is preparing the list of objectives. Right here, your engineering team basically needs to act as an unfiltered sponge. You're gathering all the raw requirements, consumer wishes, and initial technical criteria from a whole bunch of sources. For you as industrial engineering students, this means looking way beyond basic surveys. Think ethnographic studies, direct user observation, and utilizing tools like quality function deployment or QFD matrices. At this stage, just write down everything the product ideally needs to achieve. Don't even worry about how it's going to get done yet. Then we hit step 2, ordering and grouping. Now, this is where the true engineering analysis kicks in, and honestly, where a lot of novice designers fall into a cognitive trap. See, engineers love to solve problems, right? Which means they often jump straight to proposing solutions rather than defining the actual problem. So in this step, you rigorously review that raw list to group similar goals, but more importantly, you strictly filter out any proposed solutions. You are establishing purely what needs to be done. Next up is step 3, structuring the hierarchy. You take those refined groups and actually build your objective tree. You place the most general, high-level objective right at the top node. That's the root purpose of your product. Then you branch downwards into increasingly detailed sub-objectives. This strict visual hierarchy is absolutely vital because it reveals hidden dependencies and design conflicts, which we know as trade-offs. It essentially ensures your subsystems don't accidentally cancel each other out. And finally, step 4, assigning importance weights. While this sometimes gets glossed over, it's mathematically critical.
You determine the relative importance of each subobjective using techniques like the pairwise comparison method. Because let's face it, not all features are equal. Assigning empirical weights really guides your decision-making during the conceptualization phase. It guarantees that critical needs, like life-saving safety features in our medical devices, always command priority over minor aesthetic details when resources are tight. Moving right along into Section 3, separating objectives and means.
Zooming in on step 2 for a second, understanding the difference between an objective and a means will literally make or break your design process. Remember, an objective is what the product must achieve. A means is how you achieve it through specific physical components. Look over on the left side there. Increase safety and usability for the elderly. That is a pure objective. Now look at the right side. OLED screen, 500 mAh battery, physical red button. Those are means. As an engineer, if a consumer comes to you and says, "I want a big red button," you always have to ask why. The real objective there is easy emergency interaction. By locking into a red button too early in the design process, you might completely miss a much better solution, like, say, voice-activated distress signals. So always design for the objective first. Let the means come later. Okay, Section 4, building the objective tree. With our objectives carefully separated from our means, let's construct our blueprint. Based on our analysis of the really dangerous flaws in current models, the ideal elderly smartwatch must be built on 3 foundational pillars. First, it absolutely must be ergonomic and accessible, meaning it actually accommodates the physical realities of aging, like declining vision and dexterity. Second, it must offer reliable safety, focusing heavily on urgent health monitoring. And third, it has to be efficient and durable, ensuring the device is always powered and ready to perform without burdening the user with constant, annoying maintenance. So here is how the whole objective tree comes together for this product. Just look at how our 3 pillars break down into really specific, actionable sub-objectives. Under Pillar 1, ergonomic and accessible, we branch down to a clear display, which translates to large fonts and high contrast. We also branch to easy interaction, ensuring there is a physical, tactile SOS button rather than a confusing touchscreen menu that's impossible to use in an emergency. Under Pillar 2, reliable safety, we specify accurate fall detection with high sensitivity and a fast SOS signal that uses loud audio notifications to overcome any hearing impairments. Finally, under Pillar 3, efficient and durable, the tree guides us to low power consumption, aiming for over 7 days of battery life, paired with easy charging, like a magnetic or wireless dock, completely removing the frustration of those tiny plug-in cables. By looking at this tree, your entire development team has a unified, complete picture. Every single feature directly answers a specific critical user need. And finally, Section 5, conclusion and next steps. Let's wrap this up and see how this actually builds your engineering toolkit. Nigel Cross's method provides a super structured foundation that actively prevents costly design failures. By dissecting a problem all the way down to its roots, just like we did with the smartwatch's reliability and ergonomics, you ensure that your technical solutions are highly targeted, effective, and oriented entirely toward the safety and satisfaction of the end user. Now it is your turn to apply this exact framework. For your upcoming case-based learning or CBL assignment, you're going to be working in groups. Your task is to identify a flawed product in your everyday environment. You'll conduct a brief survey to capture raw user needs, and then, using digital collaboration tools like Miro or Jamboard, you will analyze those needs and construct a comprehensive objective tree of your own. Remember, you'll be graded on your ability to clearly separate objectives from means and the logical depth of your hierarchy. So, as you leave this session and walk around your campus or head back home, keep your eyes open. Look for the frustrations, the weird workarounds, the bad designs people just put up with. What flawed product is failing its users right now? And more importantly, what product will you improve next? I really can't wait to see the objective trees you build. Thank you so much for joining me in this explainer, and good luck with your assignments.